Let's talk about planning our solution and how we test our logic. In this example, we are going to figure out how to calculate the price of a desk. The problem is a carpenter, Dean's Desk Company, needs a program that computes the price of any desk that a customer orders based on the following input fields: length of desk in inches, width of desk in inches, type of wood used, and the number of drawers. And we will calculate the price as follows. Your default for any desk is a $200 minimum. If the surface, which is the length times the width, exceeds 750 square inches, you add an additional $50. If the wood type is mahogany, add $150. If the wood type is oak, add $125. No additional charge for wood type of pine. Each drawer is an additional $30. Take a moment to try and solve this problem on your own. Pause the video and use the Word document provided online. Let's walk through the solution. Our inputs: desk length, desk width, type of wood, and number of drawers. Outputs: total price. As far as a high-level task goes, we want to calculate the total price of the desk. First thing we want to do, we want to get the desk length, width, type of wood, and number of drawers. Let's go on and set the total price equal to 200 because that's our minimum. Calculate the surface. It's desk length times desk width. Let's go on and look at this if logic. Now we want to add an additional $50 if the surface area exceeds 750 inches. So let's go on and add $50 to the total price, and we have an end-if statement. Let's go on and check the type of wood with an if statement. If type of wood equals mahogany, then we want to add an additional $150 to the total price. Else, we want to check if the wood type is oak. If so, we want to add $125. Let's go on and close that with an end-if and in the other if statement. We want to calculate the drawer cost, and we will multiply the number of drawers by 30 and then get the total price by adding the drawer cost. Last but not least, display the total price. Here is another view of the solution. We need to test this solution to make sure it works as expected. As a developer, you want to test every line of code to make sure it works. Remember, you do not need to test the same lines over and over again. When you test once and it works, you need to move on. After you test all the logic, you have a working algorithm. I'm going to walk you through some test scenarios. Once you write your program, you can use the same example used in this desk checking. If you get the same results in the program test as you did in the desk checking, you know you have a good program. Remember, you need to test every line of code. When you have an if statement, there are two sides to the test, a true and a false. Make sure you keep that in mind. Let's take a look at how to desk check this logic. Okay, so let's do test case number 1. I have my input down here, and this is my output expected result. So let's go on and use 100 as the length, 50 as the width. Type of wood, let's use oak. And number of drawers, let's do 4. So here's how I do it. You can do your own version of this, but this helps me out. As I go along, I like to highlight my code. So let's look at this. Desk length. I have my length, width, type of wood, number of drawers. I am going to highlight this case as yellow. I tested total price equals 200. Surface, I'm going to calculate that. That will come out to, let's go on and make a note over here. That is 100 times 50 equals 5,000. If the surface exceeds 750, which it does, I am going to add $50 to the total price. So now, as a note over here, I'm going to say total price equals 250 at this point. End if. And these are my notes. You can clean this up as you move along. I have this if statement. It is not mahogany, but I am going to hit the else statement. And we have oak, So I will execute this if logic. And now I want to add $125 to the price. Total price equals $375. I'm not going to hit the else. I hit the end if. I'm going to highlight this end if, and now I am going to calculate. I have 4 drawers, so that equals 4 times 30 equals 120. I'm going to highlight this. I have 375 plus 120 equals 495. I will display my 495. So expected result, 495. Now you can look at this and it's easy to see what you did not test. And that's why I like to highlight these things. When you finish up, you can remove all the highlights and get rid of all these extra notes over here. This makes it easy for me to follow. That is test case number 1. Let's do another test case. In this example, we will have a length of 20, width of 20, type of wood pine, number of drawers 0, expected results 200. Let's go on and calculate that. I tested this, so I am defaulting 200 to my price, calculating my surface. It does not exceed 750, so I will remove this line. Type of wood, it is not mahogany. Now I'm going to hit that else statement. If the type of wood is oak, it is not else. Let's go on and use a different color for this one. Total price equals total price. Okay, so right now it is $200. So I can get rid of this. This is why you want to get rid of all your test notes before you go to the next test case. So now I'm sitting at total price equals 200. Now I come down here, 0 times 30, that is 0. Now 200 plus 0 equals 200. Display my total price, 200. So now I'm going to highlight that in green. So I can look at this and see I still need to test the mahogany example. So let's go on and do that. This is our third example. Let's use a desk length of 100 and width of 50. Type of wood mahogany. Drawers equals 2. Expected results 460, and I am going to use a different color. I'm going to clear all this out before I start. So I have my length, my width, my type of wood, number of drawers, which is 2. Total price, default that to 200. Multiply desk length times desk width, and this is 5,000. 100 times 50 equals 5,000. And the surface exceeds 750. So now I want to say total price equals 200 plus 50. I will execute this logic. I'm going to add another 150. So 250 plus 150 equals 400. I am not going to execute this. I'm going to jump down here to this end if. I'm going to multiply 2 times 30. 400 plus 60 equals 460. So there you have it. We tested all this logic with 3 test cases. And once you create the program, you can use the same test cases and run it through your code, and you should get the same results. Here is a recap of your test cases. Let's go on to the next example. In this example, we will create a loop to calculate the savings total amount based on an amount, a rate, and a term. Let's go on and look at that logic. Inputs, amount, rate, and term. Outputs, amount. High-level task, calculate the amount of savings. And we are going to get the amount, rate, and term. Let's go on and set the count to 1. Now we get ready to go into a loop. Do until count is greater than term. Inside this loop, we will say amount times rate plus amount equals the new amount. Display the amount. Make sure you increment your counter. Count equals count plus 1, and let's end the loop. Let's go on and create a couple of test cases to desk check this logic. In this example, I want to use 100 as the amount. Let's go on and test for a term of 0. What happens if you just skip over the loop? Is it okay? Well, let's try it. Term equals 0. Rate, let's go 10% and see what happens. So I am going to highlight this in yellow. Get amount, rate, and term. Count equals 1. Do until count is greater than term. Aha! We are not going to execute the loop, so your expected result is nothing to display. There you go. That's a good test. Let's try another one. Amount equals 100, term 2, rate 10%. Let's go on and highlight this one. I get my amount, rate, and term. Count equals 1. Do until count is greater than term. So now count is 1, term is 2. I am going to calculate amount times rate plus amount equals the new amount. I'm going to display 110. I'm going to increment the count, so now the count is set to 2. Do until count, which is 2, exceeds term, which is 2. Oh, let's fix this. Hold on. Let's put an uppercase T there. Just found a problem. And multiply your 110 by the 10%. You want to display amount, which is now $11 more. So it's 121. We loop. Now count is 3. Term is 2. So we are out of the loop. And that's it for our expected results. So we tested this logic. And you want to do the same thing when you create your programs. Here's a recap of your test cases for that example. Now, go back and just try to create some other test cases. But remember, as soon as you test that line of code, you are finished with that. There's no reason to go back and retest and retest and retest. This concludes our lecture. Thanks, and see you next time.